Hey everyone, and welcome to the Retro Channel, and today we are back with the box of Commodore 64 goodies. So I did have a look at some of this stuff in the previous video, so I'll throw a link to that up there. Basically, we checked out these two power supplies, also this little load tester, and this random shortboard. So we won't be looking at those again, but we will be taking a look at these two 64Cs, but I have no idea if either of these two work, and I also don't know what kind of state they're in on the inside. So before I turn these on, I'm just going to tear them apart and we'll take a look, see what's up. I think we'll start with this one. So looking around on the outside, it doesn't look too bad. It's a little bit dirty and there's a little bit of damage to the case up here, but beyond that, it seems all right. We are missing the label on the back, so, well, that's not going to tell us anything. And looks like these screws down here may not be the originals. Alright, it's a long board because the power LED goes over to this corner. So normally on a short board, the LED connects up here somewhere and the keyboard connects over here. So definitely a long board, most likely a 250466 revision. The keyboard does not have any of the keyboard mounts, so well, it could be any board in here. It looks like this is just a mismatch of parts. It's a 250425, so normally you'd find this in a bread bin style case. Well, the board itself looks pretty clean, and all the major chips are in sockets, so that's always nice. What isn't so great is there is a group of MT RAM on the board, so they are probably faulty, and if they're not faulty already, they're most likely to go bad soon enough. So I'm probably just going to replace all of them as a matter of course. But beyond that, everything seems okay. There's no chips in the wrong way or in the wrong places. So I'm just going to pop out the SID chip just in case, because we don't necessarily need that to power up the machine. And we'll check some voltages and then see if we get a video output from it. And maybe I'll hook up video output as well. I really doubt we're going to get anything, but who knows, it might just work. Powering on. All right. We're getting... Oh, it works. Well, that's kind of boring. I guess we'll just throw in the SID and run the diagnostic, see what happens. Now, I don't have the harness connected just yet. I want to clean up the ports before I go hooking all that stuff up. Okay, well, the SID sounds like it's working, but I do notice that the timers are wrong. So the left one says 51 seconds, which is about right, and the other one is just stuck at 809, which would be pointing towards the CIA at U2 possibly having a fault. Let's just have a quick look with the old oscilloscope. So on both of these CIAs, pin 19 is the timer input. So we should see a nice 50 Hertz square wave on both of these, or 60 Hertz if you're in an NTSC region. And there we go, that's CIA1. It's not a perfect square wave, but it's pretty much good enough for the Commodore 64. And on CIA2, yep, it's getting the same thing. That shouldn't be a big surprise because they're both connected directly on the board, but it's always worth checking. There might have been a bad contact on that socket. I somehow doubt it though, so let's swap these two over. I dare say the fault will follow the particular CIA. All right, CIA swapped. Let's see what happens. Oh. So for a while there, they were keeping the same time, but now the first one has jumped to 9:49. So definitely a fault with that CIA, at least for the timer circuit. It may still work reliably otherwise. So I'll pop the board out, give these a good clean, and we'll do the full harness test. And as is fairly common with these 425 boards, we have the old crinkly solder mask. It's actually missing a big chunk here, but this is pretty much how it left the factory, so there's no actual issue with this board. Alright, diagnostic harness is all hooked up. Let's see what we get. Aha. Keyboard bad, control port bad. Now it does say U18 is also bad, which is the SID, and that'd be because we had the joystick port error, which the analog side of is handled by the SID, and the digital side is handled by the CIAs. So I think the SID is a red herring there, and I reckon it's just caused by that dodgy CIA. So it does seem to have further issues. Let's swap it out. Actually, before I put this one in, let's swap these back around because I think the error should probably move to the serial port, which is mostly handled by the second CIA. Yeah, now we have cassette port, serial port, and user port, and it's identifying both CIAs as bad. So that's how that can kind of trip you off. The diagnostic test isn't 100% foolproof, so always be wary of that. Out of curiosity, let's just have a look on the scope and see if we can see anything abnormal from this CIA. So I've just swapped over to the no RAM check diagnostic, which I'll leave a link to in the video description. It basically just skips the RAM checks and goes straight to the port tests and the sound tests. So we're not sitting around waiting for the ports to actually get tested every time. So let's take a look on the scope. And looking at the pinout for the CIAs, we can pretty much ignore all the data and address lines because they're going to have fairly normal activity on them. Otherwise, they'd be corrupting the rest of the system and it wouldn't boot at all. So I think we can ignore them. What I'm interested in is pin 39, which is apparently serial input-output. Bring this out into roll mode, see if we can just spot any little peaks. Oh yeah, there we go. So there is activity there. I wouldn't expect too much to be going on. In fact, we can confirm that just looking at the other CIA most likely. Yeah, it looks about the same. The address lines we can ignore, reset we can ignore. Obviously there's going to be a clock signal. There is a pin called flag, which is handshake input. And well, yeah, that's definitely got a lot of activity on it. I think that's fine. There's the chip select, which is active low, and we do get a little blip on that, so it is being selected correctly, and that makes sense because the chip select is probably coming from the PLA or something, and swapping the chips around, the fault followed the CIA and not the actual placement of the chip itself. There is a read-write pin which also has activity. We already looked at time of day clock. What is this? This is apparently handshake output. Yep, and there's a little blip of activity on that as well, so I'm guessing that's fine. And the rest of them are the port input and outputs, which is basically the main function of the CIAs. So if we have a look at some of these, we should see activity as the user port and the serial port are being tested. Nothing on pin 3. Pin 4 is just stuck low apparently. In fact, it looks like all the port pins, so everything from pin 2 all the way up to pin 17, are either just stuck high or low, and there is zero activity on them. And that's probably why the CIA at least partially works. It's not crashing the system or anything, it's just not working with the input-output on the port pins. In fact, let's just swap these around again, and we'll see if we have activity on those pins once they're switched around. With the CIA swapped, straight away we see activity on pin 2, and there's a little blip on pin 3. A few blips on pin 4. Yeah, we're definitely seeing some activity on these pins now. And if we go back to our faulty CIA, which is now in the other socket, again, everything is just stuck high or low. So yeah, half working CIA, it's just all the ports on it are shot. Let's pop in a known working one. And there we go. Everything appears to work perfectly fine. Not seeing any issues there. The keyboard reports is open because I didn't reconnect the loop back, but that's not a big deal. Now the other thing I'm noticing is that SID sounds a little bit iffy, so let's give that a proper test. Go. Oh. Number keys are not working. Alright, seems some of the keyboard is not working. Let's test that first. Yeah. Arrow key doesn't work. Ooh. So from the arrow key all the way up to 5, we get nothing. Oh, 9 doesn't work. Oh, all these keys over here. Right, there are a number of keys on there that are not functional, and it doesn't seem to just be bad contacts. So I wonder if that matches up to a certain part of the keyboard matrix. Let's take a look. So I've just gone through and highlighted the keys that are not working and also the columns that they're attached to. It seems most likely that these columns are at fault. If it was certain rows that were at fault, then we'd see more keys in a particular row being faulty. But this all seems to point more towards particular columns being faulty. So if you press a particular key, it's just going to connect, say, row 4 with row A, and that's the spacebar. So it looks like we'll be tearing this keyboard apart and taking a look in there as well. So before I do that, let's just spray some contact cleaner in this connector, just in case. Yeah, that didn't seem to help at all. Okay, let's pull this keyboard apart. All right, let's see. Well, at first glance, it doesn't look too bad. I'm not seeing any broken traces or anything. The contacts themselves look okay, but I don't think it's a contact issue. I'm sure it's going to be... Ooh. There's a trace there that's missing a little bit of solder mask. I don't think that's a big deal, though. So most of the keys that weren't working are around this area, and the board in this area looks okay. We can see that this trace up here connects to the first few keys, so this must be column A. Let's see if we can get connection from there. Has that got tape over it as well? It does. Get rid of this old tape. So we should have a connection from up here back to here somewhere. In fact, it is written on the board. There's column A right there. So there to there, that's the space bar, which was working. If we go around to the Commodore key, yeah, that's quite a high resistance just between the space bar and the start of the Commodore key. 650 ohms. So that's a lot more than I'd expect just from this piece of trace and the 2 carbon contacts. Looks like there might be a bit of damage to it just up here. So yeah, it looks like there might be a bit of damage to the board just around here. So I'm just going to reveal a bit of copper under there. We're still getting nice low resistance there. And then we get 390 ohms to the Commodore key. And then if we move up to number 1, yeah, 2.2K. And then 1.4 and about 750 ohms. It's kind of weird that this one, which would be number 2, actually has the lowest resistance, even though it's right at the end of the trace. So yeah, I'd say just bad carbon contacts on this board. I mean, they don't look too bad, but I guess that's the only reasonable explanation. So yeah, maybe we just have some bad carbon contacts. So I'm just going to go over them with a light bit of IPA. You don't really want to scrub at these things, otherwise you'll take the carbon coating off, but just want to give them a light cleaning. Just see if that made any difference. 700, 1.5, 2.3. Not really. Well, it certainly seems like the trace is fine. We're getting 0.8 ohms to the end of the trace, and we can even go back to the actual wire itself. Yeah, 1 ohm. It's just these contacts that are bad. So even after doing a couple of experiments with, a bit more IPA and even Windex, I still get the same result, around 2.3K to that first contact. So it's basically shot, and I don't even know if something like this, which is like a carbon adhesive thing that you'd apply to these old contacts, I don't even know if that'd work, because if that part of the carbon pad is shot, then we're basically adding another layer on top of that. So if anything, I'd imagine the resistance would go up even higher. Right, so I thought I'd give this stuff a try anyway, just to see what happens. So I've applied it to these first two contacts here. I'll show you this one first. So this is just the carbon paste on top of the original contact. And yeah, it's actually gone up to 3.3 kilo ohms. So what I did with this one is actually scrape off the original carbon contact and then apply the paste directly onto the bare board. And if we look at this one now, we have around 100 ohms, possibly less. So that's kind of what I thought would happen. If we apply carbon paste to an already bad contact, it's just going to increase the resistance, but it seems that scraping off the original contact and then putting that paste on does seem to work. So I'm just going to scrape everything off this second contact and then I'll apply some new paste and see if we get a good result. So just from scraping at that pad, yeah, it's actually gone up slightly. We're now getting around 800 ohms. What I did with this first one was just expose a bit of the copper trace going to the pad itself, because that should be practically no resistance. So if we check, for example, from here to the exposed copper, yeah, we get 1 ohm, and we'll also get 1 ohm on the other side. So what I want to do is just coat from here all the way over this pad to this other bit of exposed copper, and that should hopefully restore this one as well. It does seem you need to mix this stuff a little bit. I don't remember when I bought this stuff. It was probably a few years ago, and it's just called Keypad Fix by Anders Products. No idea where I got it from, but I'm sure Google will reveal something. So I've just mixed it up. I'm just going to apply not too much, just a small amount. That's probably enough. Probably should use a little paintbrush for this. If this is successful, which I think it will be, then I'll just go around and do the rest of the dodgy pads on this board, and then we'll give it another test. Because I'm impatient, we'll just use the heat gun just to get that to set quicker. Yeah, okay. It's down around 100 ohms. Not the greatest job I did on that one, so I might do that again, but this does appear to work. So I'm just going to jump ahead to when I've done all of these, or at least all the dodgy ones, and we'll put this back together and give it a proper test. Right, we are back, and I think the keyboard should be now good to go. I did start by just scraping off some of the old carbon pads and replacing the carbon on top, and then I realized that the actual pads themselves all seem to be perfectly fine. They all read around 70 ohms, and that includes the ones that I thought had issues. So the actual carbon pads on top don't seem to be the problem. It seems like the layer in between has developed some kind of issue. So you've got the copper layer on the bottom, and then there's another layer which is what the actual carbon pad adheres to, and it seems like that middle layer is where the problem was. So what I ended up doing was exposing a little bit of copper on the edge of each pad and then putting a little bit of this carbon adhesive on top. So we've basically connected the exposed copper with some fresh carbon to the original carbon, and that seems to have solved all the problems. Everything seems to be around 100 ohms, which sounds good to me. So I'll get this reassembled and we'll test it out again. On a side note, this keyboard is a little different from the ones that you normally see on a Commodore 64C. You either have the ones with the printing on both the side and the top of the keycap, or you have the ones like this with everything on top of the keycap and the sort of smaller font. But as you can see from this keyboard, it has sort of the bigger font here, but it also has everything printed on the top side. So this is a bit of an oddball keyboard, not one that I've come across before, at least not on the Commodore 64C. And I don't know if I just got unlucky or if it's a common fault with these Action branded keyboards. All the other ones seem to be made by Mitsumi. So there's a little trivia for you. Let me get this reassembled, we'll test it out. All right, let's see how this goes. Oh, shift lock was on. Return doesn't work when shift lock's on. Had me worried for a second. Okay, keyboard test. a good start. Perfect. No issues whatsoever. Cool. All right, now, the thing that I was going to check out is the SID, because it did sound a little bit off. And yeah, I'm not going to play through all those tests, but what I did notice was the triangle wave sounded a bit iffy. So let's just set this to triangle, and we'll just do modulation. Yeah, that's not right. Oh, and we just lost the triangle wave. Yeah, it's kaput. So there we go, 2 marginal parts and a marginal keyboard. It's kind of funny that, you know, if you just powered this machine on normally, like we first did, it appears to work, but it's only once you run a bunch of tests on these things that you realize that, you know, there are actual issues here. So always worth thoroughly testing these machines before you just assume that they work just fine just because they power on normally. So I'm just going to put all this aside. Obviously this case needs a clean, and I'll probably pull apart the keyboard again so I can clean that too. But for now, it mostly works. Just needs a SID. And I need to get my CIA back out of it at some point. So that brings us to the final machine. This, I believe, has a short board inside. The case itself looks fairly decent, a little bit dirty, at least it's got a label on it. The warranty seal is of course broken, even though it's still kind of intact. Let's take a look inside first, make sure everything looks okay, and then we'll see what this does when we power it on. Yep, definitely a short board in this one. At least it's got the keyboard mounts. Alrighty, everything looks pretty good. Can't see any major issues. Can't see any minor issues. Looks clean. Don't see anything out of the ordinary. I get the feeling this will just work. Yep. Because it's a short board, and that's usually what they do. Check some voltages. AC looks good, no surprises there. And the DC from the power supply, yeah, 5 volts. And yeah, these boards don't make much use of the AC side beyond that, so we don't have the 5 and 12 volt regulators. I think there's a Zener diode that does some of the voltage regulation for like the SID, I think. Pretty much everything else on these boards runs directly off the 5 volt supply from the power supply. So yeah, that all seems good. It appears to be working. I'll do some proper tests and we'll come back if I find anything out of the ordinary. Got control port bad on the diagnostic, but I think that could be a false positive or a false negative. The SID does sound fine. I'm just going to switch over to the no RAM check diagnostic, just so I'm not waiting too long. And now we get control port okay, so it's probably just a bad connection. I didn't actually clean the ports on this one before I hooked up the harness. Yeah, it seems fine. Yep, no issues with the SID on this one. Perfectly fine. Perfect. Nothing wrong with this machine whatsoever. The owner did want to get a recap done on this one, so I'll do that off camera. It's not that exciting, to be perfectly honest. But Well, I think that's about it. I've got a few C64s to clean and possibly throw in some Jiffy DOS mods or whatever. But yeah, beyond that, oh, I think they wanted a new RF replacement, so I'll do that as well. But yeah, all the recapping and cleaning and swapping out RF modulators, I mean, I've shown all that before in the past, and so have many other channels. You know how it goes, so I don't think I'll bother including that in this video. I think we will just leave it here. So I hope you found these 2 episodes interesting. Certainly something different with that keyboard. And yeah, thank you all for watching. A huge thanks to the people that support the channel on Patreon. If you want to do the same, links to that are down below. And that is it. So I will catch you in the next one. Bye. Oh, it means I get to do some soldering.